Good morning to all. Myself, Dr. Nigamia from Aerospace Engineering Department. Today, I'm going to take one topic from Aerospace Propulsion, subject for second year aerospace students. If the topic name is performance parameter of aircraft engines. So in that performance parameters, the why performance matters is required for the aircraft engine. So first one is safe operation. So in that cases, the takeoff and landing, efficient screws, these are all things it will be checked before the takeoff and before the takeoff the vehicle. Next one is the economic efficiency. So here we will check the uh, fuel efficiency. It can be reduce the operation cost and it can be reduce the passenger fare. These are all things. And next one is real-time monitoring. So in that real-time monitoring, so each and every takeoff and landing, we will check the health tracking and flight optimizations. Next one is the in that design stages, the key uh, performance parameter overview. So the first one is a thrust. So in that thrust, it is a forward force. It can be used to forward the aircraft. So in that thrust, it can be measured by the newtons or pounds. Next one is the specific fuel consumption. It can be calculated by the ratio of fuel flow by unit thrust. Next one is thermal efficiency. It can be calculated by the work done by the fuel energy during the inlet. Next one is engine pressure ratio. It can be calculated by the inlet pressure ratio divided by divided by the thrust output. Now, and last one is exhaust gas temperature. So in that exhaust gas temperature, so it can be used to indicate the engine health and combustion efficiency. And next one is the additional important parameters are first one is the power output. So in that power output, it can be used to uh, increase the thrust during the takeoff. Next one is the bypass ratio. So in that bypass ratio, it can be improve the aircraft efficiency and reduce the noise during the flying conditions. And mean effective pressures, it can be used to uh, maintain the pressure during the flying conditions. Next one is the engine weight and size. So in that engine weight and size, these are all things it can be developed in that aircraft designs conditions. Next one is the interpreting performance graph. So here that graph it can be draw with the help of first one is the thrust versus altitude. So if the thrust decreases with the altitude due to the lower air density, and next one is the specific fuel consumption with thrust, and next one is the efficiency curve. So in that efficiency curve, so we will check the thermal uh, coordinator and thermal temperature. So we will check the temperature of the aircraft during the takeoff. And next one is health trends. So in that health trends, EPR and EGT patterns reveal the performance of the health trends. And the next one is high bypass turbofan advantages. So in that high bypass cases, it can be monitor the following things. First one is a low specific fuel consumption. Next one is a significant noise reduction, and the third one is the enhanced propulsive efficiency. So by you see that figure, so in that figure, the turbojet it have a more amount of large muscle during the uh, takeoff conditions. And next one is the prototype stages. So here the we will take the one case study. So in that case study, the turbofan engines can be used for this case. So in that case, the 16% of fuel efficiency we will gain during these cases. And the next one is the 75% of noise can be reduction during these cases, and 10% as specific fuel consumption it will be improved by applying these conditions. And these are all the data sheets, the conventional and geared turbofan. And by summary, so we by conclude this topic, the understanding is the master's rest and physical consumption, and by innovation means the geared turbofans, and by monitoring the continuous monitoring of the UGT and EPR. So thank you. So we will catch you on next topic on next slide.